In this video, we are going to cover the sequences, which are the ordered collections in Python. You'll recall that there are three types. There are lists, tuples, and strings. So everything that we say here will apply equally to those three types, with the caveat that tuples are immutable and strings are immutable and can also only contain text. So here we have a sequence, we call it A, and it has 5 elements. So the length of A is equal to 5. Let's say we want to reference one of the elements in this sequence. We do that using its index. So the index in Python is an integer beginning with 0, which corresponds to the very first element in the sequence, and in this case ending with 4, which is the last element. In general, if we have a sequence with n elements, then the index goes from 0 to n minus 1. So let's see an example of this in code. Okay, so here we have some code. I've defined a list called listx and a tuple called tupley, and I've given them the same content. So I know that listx is a list because it is defined using square brackets, and tupley is a tuple because it's defined using parentheses. So here's the first question. How many elements does listx contain? Well, I can find the answer to that using the len, or length, built in and passing in listx. And that tells us that listx has 3 elements: the 4, the high, and finally the list 1, 2, 3. So don't be fooled into thinking that the numbers 1, 2, and 3 are elements of listx. They're not. 1, 2, and 3 are elements of a list, which itself is an element of listx. All right, so what if I wanted to somehow address or reference the first element in listx? I do that by typing listx and then opening square brackets and passing in the index to the item that I wish to reference. In this case, 4 is the first element, so I pass in the index 0, and that gives me the 4. If I passed in a 1, it would give me the high, and if I passed in a 2, it would give me the list 1, 2, 3, which we can verify is a list using type. It tells us it's a list. Okay, what if I wanted to modify somehow the list? So right now the list starts with a 4. If I want to replace that 4 with a 5, all I do is I assign the first element in listx, I assign it a 5. And now listx starts with a 5. Okay, I can do similar things to the tuple. I can reference the first 4 in the tuple, or the high, or the 2. However, I cannot modify it. So if I say tupley, the first element or the 0th element is equal to 5, I get an error. The error says tuple object does not support item assignment. I cannot do this. Okay, so one last thing to note is that we can also use negative indexes, negative numbers to index items in a sequence. They start with -1, references the last item in the sequence. And then the second to last is a -2, the third to last is -3, and so on. So I can here say tuple -1, and that gives me the string. So that's a very, it's a nifty way of addressing or referencing the last item in a sequence. We've seen how we can obtain a single item from a sequence using its index. Next, we're going to see how we can obtain multiple items from a sequence using the technique of slicing. So there are 2 types of slices, contiguous slices and periodic slices, and we're going to cover them both. The example is a sequence called A that contains 10 random objects in it. So first, contiguous slices. The word contiguous here means that the slice that we're going to get has no gaps in it. So all you really have to specify is where it starts and where it stops. Let's say that we want to get items from index 1 up to index 7. The syntax then would be as follows. We use the name of the sequence, and then just as with simple indexing, we use square brackets. And within those brackets, we're going to put now the slice index. That slice index consists of the start value, then a colon, and then the stop value. So what may seem a little strange here is that while what we want is to go up to 7, the stop value is being set to 8. The reason for that is that in Python, the stop value is non-inclusive. So when you say 1 to 8, that 8th value will not be included in the slice that's returned. Okay, up here I have a somewhat more formal statement of the syntax that includes the default values. So it's optional to specify what the start and stop are going to be. If you do not include, say, the start value, then it will be set to 0. And that means that the slice will start from the very beginning. Then if you do not include the stop value, it will be set to the length of the sequence. In this case, the length is 10. So since it doesn't include that stop value, it will go up to the 9th, or the end of the sequence. Okay, how about periodic slices? Sometimes you do not want every single value, but you want to skip over some values. In this example here, I want every other value, starting from the 1st and ending with the 7th. In that case, we have to specify the step. So the syntax is very similar. We have the start and the stop, and then we put another colon and we specify what the step value is going to be. So the step value could be 2, 3, whatever gap we want to leave, and it can even be negative. And in that case, it would go backwards. So let's see some examples of this. Here's a list. It has all of the numbers from 0 to 6 just spelled out. So each of these words corresponds to its index. That'll make it a little bit easier to follow. So let's say we wanted to make a slice, and we wanted that slice to have 1, 2, 3. So we'd say A, square brackets, and then the start value, and then the stop value in this case will be 4, because remember, it's non-inclusive. So that gives me 1, 2, 3. If I wanted to go all the way to the end, all the way to the 6, then because the length of this list is 7, I could say 7, and that would go all the way to the end, but it's actually easier to just leave out the stop value, and it defaults to going all the way to the end. And same with the beginning. If I do not specify a start value, it's going to start at 0. Okay, let's try out the stepping. Let's say I wanted to extract 1, then 3, then 5. Then I'm starting at 1, I'm ending at 6, and I'm stepping every 2. Okay, I could also step, say, every 3. And then I get 1, 4, and then stepping another 3, that puts me beyond the limit of 6, so it just stops at 4. Okay, what about backward stepping, going backwards? If I wanted to go from 5 down to 2, I would start at 5, that's my starting index, and in this case I'm going backwards, so I'm going down to 2, so I want to end at 1 because it's non-inclusive, and my step would be -1. So that goes from 5 down to 2, and I can also use larger backward steps, say -2, that goes 5, 3, and then the next would be 1, but that's already outside of my range. So finally in this video, I want to talk about unpacking of sequences. So here's the description. Unpacking is a shorthand syntax for assigning the elements of a sequence to variables. So let's say you have a sequence and it has n elements in it, and you want to assign each of those elements to a different variable name. Now you could do this with n lines of code. The first one being x1 is equal to a0, x2 is equal to a1, all the way down to xn is equal to an minus 1. But Python offers a simpler syntax, which is this one right here, where you list the variable names, and then you just say that that's equal to the sequence. This will throw an error if the number of names in the list is different from the number of elements in the sequence. So let's see this in action. Here we have a list A, and it has 3 elements in it, 0, 1, and 2. And let's say we wanted to assign variable names to each of those elements. So as I said before, we can do that with 3 lines of code. A1 is equal to the first element, A2 to the second, and A3 to the third. And then we can print all 3 elements, and that works just fine, assuming that I define A first. So, well, with unpacking, we can do the same thing, but we can do it in a single line of code. So we'd say A1, A2, and A3 is equal to A. That's unpacking, and it works just the same way. Okay, so why is this interesting? Why do we need to learn unpacking? Well, the main reason, it has to do with functions. That's where it really shines. So let's take this function, get information. Let's say it does a bunch of work, and then at the end, it determines that the age is 50, and it's going to return the age. So I can call this function. I can say age is equal to get information, and then if I print age, it gives me the 50. It works great. What we have not talked about is what if we have several things that we want to return in addition to the age, the weight, and the height. We've only seen in functions that you can return a single object. So the way you do this in Python is the way you'd imagine. We package those items that we want to return into a tuple or a list. So let's package it into tuple. We say age, weight, and height. Now we're going to return some tuple. Let's call it information. And let's just verify that what we're getting on the outside is indeed a tuple. Okay, so what we can do since we're not really interested in keeping this as a tuple, we can unpack the tuple on this very line. So we can say age, weight, and height, and this is going to unpack the tuple that is being returned by get information, and then we'll have those as separate variables. So there you go. It works just fine. And the kicker is that we can also simply eliminate the parentheses. So when you put something that's comma separated like this and you don't include the parentheses, Python's going to assume that what you want to create is a tuple. And so now we have a syntax that looks just like returning a list of multiple things and receiving them on the other end. So that's unpacking. And that's all for this video. I'll see you in the next one.